guys, in this crash course video, we will talk about spectroscopic methods. Medyo mahaba itong chapter na to and it's really a big deal in your board exams, both in the chemist and chemical technician licensure exams. Kailangan guys, malawak yung knowledge ninyo about spectro. So just in case hindi pa kayo super familiar sa concepts, sa terminologies, sa calculations, sa applications about spectro, then you must read the specific chapter na meron sa mga references natin about spectro. Okay, do that and then of course, watch and rewatch this crash course video para guys makapag-provide tayo ng enough knowledge para sa inyo. But kung familiar na kayo sa spectro, then that's good. Ibig sabihin guys, meron kayong mga maaalala, meron kayong mga mahuhugot na alaala from your previous background or sa previous na lessons ninyo before no undergrad kayo. Okay? So guys, ito ngayon ang slides natin. Let me share with you. So alam nyo ba guys na ang spectroscopy, in particular yung visible region sa electromagnetic spectrum, this is one of the most widely used methods of analysis. So it's very important na alam natin to. Okay? Hindi lang dahil para sa exam, but in your future careers or sa mga future jobs ninyo. So under spectroscopic methods, guys, here are our topics. I'll give you first an overview of spectroscopy. And then of course, kailangan, ito yung isa sa mga highlight ng video or ng chapter na to guys, itong topic on instrumentation. Of course, most of the topics we will talk about is spectroscopy based on absorption, although meron din tayong based on emission towards the end of this video. We will also be giving emphasis on UV spectroscopy, one of the most widely applied guys na method of analysis in the lab nowadays for sure. Marami sa inyo guys naka-experience na ng paggamit ng UV spectrophotometer. And of course guys, we will also discuss about AAS or atomic absorption spectroscopy. Okay, so let's start guys with a recall on the different regions of the electromagnetic spectrum. Of course, sobrang common sa chapter na to guys ang UV, visible, and then later sa special topic natin meron tayong IR, NMR, radio waves. Yung NMR, yung radio waves yung ginagamit kayo sa NMR. So ito guys ang different portions ng electromagnetic spectrum. So here you would see na yung very thin slice which is for the visible region. Ito yung nakikita guys ng eyes natin. So, the colors that we see, Roy G. Biv, diba? Red being the longest in wavelength but lowest in energy, and violet being the highest in energy but shortest naman guys ang kanyang wavelength. Okay? So, you already had this sa Gen Chem lesson natin, diba? So, meron din kayong ganito sa basic chem ninyo. So this is just a review, guys. And then, ito na. So let's define spectroscopy. It's the study of the interaction of electromagnetic radiation and matter. A spectroscopic measurement is possible only if the photon's interaction with the sample leads to a change in one or more of its characteristic properties. You have this, guys, in your manuals. Ito ang table telling us about the type of energy transfer, region of electromagnetic spectrum, as we have seen in the previous slide, and yung mismong tawag guys sa spectroscopic technique. Okay, so you might all be familiar with UV spectroscopy, atomic absorption spectroscopy, IR or infrared spectroscopy, and so on. Okay, so now guys, we should speak the spectral language kasi ang daming terms dito guys na kailangan maging familiar kayo at maunawaan nyo of course in the course of our lesson. Okay, ito ang isa sa mga subtopics din kanina, instrumentation. Pag sinabi guys na block diagram, ito yung correct order ng components ng isang instrument. So we have the source, number one, source of light or source of radiation. We have two to be general guys, ang tawag talaga dito, yung mas generic na term, no, wavelength selector. Pero later, makikita ninyo bakit monochromator na yung nakalagay dito. So number 2, I repeat, generally we call it a wavelength selector. Number 3, your sample. Saan nilalagay yung sample? Sample compartment. Number 4, detector. And guys, the last one, the fifth one, is our readout or display. Okay? So again guys, ito yung correct order, ito yung tamang sequence ng components inside our spectrometer. So, para mabigyan kayo guys ng magandang preview or magandang point of view, no, yung mga components, I will let you watch this short video clip para guys mas makita natin yung tamang yung tamang order nila at yung reason bakit ganun, bakit nasa unahan yung source, nasa dulo guys yung readout or display. So let's watch this video clip guys.
Here's how a spectrophotometer works. A lamp provides the source of light. The beam of light strikes the diffraction grating, which works like a prism and separates the light into its component wavelengths. The grating is rotated so that only a specific wavelength of light reaches the exit slit. Then the light interacts with the sample. From this point, the detector measures the transmittance and absorbance of the sample. Transmittance refers to the amount of light that passes completely through the sample and strikes the detector. Absorbance is a measurement of light that is absorbed by the sample. The detector senses the light being transmitted through the sample and converts this information into a digital display.
All right. So guys, nakita ninyo from the source, and then diffraction grating kasi yung ginamit guys na term for the wavelength selector, the sample that you see there na mag-absorb ng light or ng radiation, and then the detector and the readout. O, diba?
Here's how a
Very simple guys yung approach doon sa video clip na yon. Now, let's discuss the components in detail. The first part again is the source of light or radiation. So we have here several lamps, okay, in this picture. Guys, ito ang mga ginagamit, no, sa iba't ibang types ng spectro technique. So for absorption and scattering, we use radiant energy. For emission and photoluminescence, ang mga pwedeng gamitin ay thermal, radiant, or chemical energy. The requirement for the source of light is that it must provide an output that is both intense and stable. We have two types of sources, continuum and line sources. When we say continuum, guys, this emits radiation over a broad range of wavelengths. Examples are hydrogen and deuterium lamp, tungsten lamp, and xenon arc lamp. On the other hand, line sources, they emit radiation at selected wavelengths. So later guys, makikita ninyo sa AAS ang hollow cathode lamp. Pwede rin guys ang mercury vapor lamp and laser. Okay? So again, dito guys magmumula yung light, yung radiation, the source. So we have different, okay, we have varying examples ng lamps na pwedeng gamitin for spectrometers. Next is the wavelength selector. Ito guys, itong nasa picture, ang tawag dyan filter. Filter is one of the simplest way para makapag-select ng wavelength. Ideally guys, dapat may high throughput of radiation and narrow effective bandwidth ang wavelength selector. However, ang filter guys, hindi siya kasing modern or kasing effective ng ibang wavelength selectors. Nakagamit na ako na to before. So meron kaming tinatawag na Spectronic 20, and then meron kaming square shape ng mga filters to be used at specific wavelengths. Medyo tedious, no? Kasi kapag may monochromator yung instrument mo, kumbaga, mas mabilis mag-select guys ng wavelength na gagamitin mo for your analysis. Okay? So, ang filter guys, nag-work siya by using absorption or constructive destructive interference to control the range of selected wavelengths. Okay, so ngayon mas ginagamit na guys ang tinatawag na monochromator. So parang kamukha guys ito yung nasa video clip kanina, no? So ang binanggit nga na term kanina, yung diffraction grating. Okay? So an alternative approach kasi hindi nga ganun ka bilis, no? Okay, hindi magiging continuous ang selection ng wavelength gamit guys ang filter. An alternative is the use of a monochromator. It provides continuous variation of wavelength Kaya ito na ngayon yung present sa mga modern spectrophotometers. We call this the monochromator. Mono means one, di ba? So madali lang guys mag-isolate ng wavelength, mag-select ng wavelength if you have the monochromator inside your spectrometer. Next component is the sample compartment. We call this very small piece of glassware a cell or a cuvette. Ayan guys, ang iba't ibang dimensions ng mga cuvettes. The sample compartment provides a light-tight environment that limits stray radiation. O take note guys pag sinabi natin stray light or stray radiation, this radiation does not come from the source. Well, it could happen kung naka-open yung sample compartment while you were doing the analysis. So in order to avoid the entrance or the entry of stray radiation, we would like to close the sample compartment during analysis. Ang gusto guys natin na light na mag-reach sa detector is the light, transmitted light coming from the sample. Okay? So magkakaroon guys ng difference, magkakaroon ng discrepancy sa magiging absorbance ng sample ninyo if there will be the presence of stray light or stray radiation. Samples normally are in liquid or solution state and are placed in cells constructed with UV-vis transparent materials tulad ng quartz, glass, and plastic. So for sure guys, nakinig nyo na before na ito yung common materials natin for UV-vis absorption. We call them cells or cuvettes. They have windows that are transparent in the spectral region of interest. Ideally, cuvettes must have windows that are perpendicular to the direction of the beam in order to minimize reflection losses. You must be very careful when you handle your cuvettes. Okay, kailangan guys maingat. Of course, there are certain guiding principles sa paggamit guys ng cuvettes natin. Now you may ask, which cuvettes lang ba ang pwedeng paglagyan ng sample? Pwede rin guys ang mga test tubes. There are actually certain instruments guys that allow the use of test tubes as sample compartments. So, ano yung mga kailangan i-take note pa natin guys in using cells or cuvettes? So kapag guys na UV, okay, kapag nasa UV region na guys yung magiging working wavelengths ninyo, dapat ang gagamitin nyo na type ng cuvette ay quartz. It should be made of quartz, or we can call it a fused silica cell. So a quartz or a fused silica cell is required when working below 300 nanometers, where other materials show a significant absorption. The most common cell path length. So path length ng term natin guys. Mamaya malalaman nyo sa computation kung ano yung symbol for path length. Yung common guys na path length in the UV-vis is 1 centimeter. Although there are cells or cuvettes na ang path length ay 2 centimeter, may umaabot pa nga guys hanggang 10 centimeters. Okay? Also, ito, kailangan nyo guys iwasan kailangan i-avoid natin that we introduce fingerprints, grease, or other deposits on the walls because they may alter significantly the transmission properties of a cell. Thus, it is imperative to thoroughly clean cells before and after use, and windows must not be touched. So kailangan guys, iwasan natin i-touch yung transparent windows kung saan dun dadaan yung light. So we have to avoid touching that. Now, you must prepare a lint-free tissue paper along with you when you accidentally touch yung mga windows na yun sa cuvettes. Okay? Match cells, ito pa should never be dried or dried by heating in an oven or over a flame. Oh no, wag tong gagawin because this may cause physical damage or may change the path length of your cuvette. Matched cells should be calibrated against each other regularly with an absorbing solution. And take note that the quality of spectroscopic data is critically dependent on the way that cuvettes are used and maintained. So you must never do this, guys. So binanggit sa 2 paragraphs kanina. You must never do that. Otherwise, hindi magiging ganun kaayos yung magiging results ninyo. And plus the fact, guys, na baka hindi nyo na ma-reuse pa yung mga cuvettes ninyo. Okay? So with proper use, you can use your cuvettes for a long time and the analysis you will be obtaining from your experiment will be, of course, as accurate as possible. So here again, or some examples of cuvettes. All right. Next, guys, the next part, number 4, is our detector. To obtain spectroscopic information, the radiant power transmitted, fluoresced, or emitted must be detected in some manner and converted into a measurable quantity. So, of course, guys, after light passes through your sample, some of the light will be transmitted, di ba? Fluoresced or emitted. So, ano yung portion ng instrument for this purpose? This is the detector. A detector is a device that identifies, records, or indicates a change in one of the variables in its environment, such as pressure, temperature, or electromagnetic radiation. One example of detector is what we call a transducer. It converts various types of chemical and physical quantities into electrical signals tulad ng charge, current, or voltage. An example, guys, of a very common transducer is what we call PMT, or photomultiplier tube. It is one of the most widely used types of transducers for detecting UV-vis radiation. Okay, so we are now at the fourth component, the detector. And the fifth one, how will you know, di ba, kung ano yung naging result dun sa analysis mo? You must have the signal processor. So in the video a while ago, you have seen this, di ba? Ito guys, yun nga lang, hindi ito katulad ng mga modern na spectrophotometers. So this one is kind of old, or nasa ano pa, later, kumbaga mga earlier model pa to, no? But you can see na digital din naman yung display. So, wavelength 380, tapos may absorbance. Although guys, sa lab, no, we recommend, kapag mga ganito kalumang instrument, we recommend na transmittance yung gamitin na value and then just convert the absorbance using the formula A is equal to negative log of T. Okay? So, ano guys, ang purpose ng signal processor? So we have a device such as a meter or computer that displays the signal from the transducer in a form that is easily interpreted by the analyst. So ito actually medyo okay nga to na digital, no? Kasi the Spectronic 20, yung model na ginagamit namin sa lab before, ito pa yung guys yung analog. May ganun pa, no? Wherein you will match kung asaang number siya naka-point. So ganon, analog pa yung display niya. It can also be used to calibrate the detector's response, to amplify the signal from the detector, to remove noise by filtering, or to mathematically transform the signal. And guys, ang mga example nga ng signal processor, as I've said earlier, pwedeng analog. Ngayon, digital na yung mga display, and yung mga naka-connect na rin guys with computers equipped with digital acquisition board. So guys, in the next slide, we will see an old model of a spectrophotometer, paano siya ginagamit, just so you have an idea for those na hindi pa familiar or for those na familiar na, para ma-recall na guys kung paano gumamit ng spectrophotometer. And then in the next slide naman, yung modern version. Okay, so yung digital version guys, well, digital din naman yung next slide natin. Although kasi yung more modern spectrophotometer na ipapakita ko sa inyo, ito na ngayon yung mga ginagamit natin sa lab. Okay? Kasi guys, mas mabilis, o 'di ba? Mas mabilis yung analysis with the more modern versions. Okay? So let's watch this, guys.
First, let's go over the parts of the spectrophotometer. First, you have the sample compartment. The lid opens and closes to put your sample inside. You have the wavelength control knob to change the wavelength. This is called the zero control on the left-hand side. And this is the transmittance absorbance control on the right-hand side. Right on top is the mode select button. And when you push the mode select button, you'll notice that the LED will change positions. And so will the readout. To begin using the spectrophotometer, you have to have your samples ready. So first, you should prepare a blank solution. And the blank solution has everything in it except for the molecule or compound you wish to measure. Then you should also have a tube which contains a sample which you want to measure. When taking readings, it's best to go ahead and use the transmittance as the way to set up the machine and also to take your readings. The transmittance scale is linear, so it's easy to set the 0 and the 100%. So when you're ready to calibrate the machine, be sure to push the mode button several times until you have the transmittance value highlighted before you begin. In order to start taking a reading, you have to first set the machine up. So to do so, first thing you must do is use the wavelength control knob and adjust the wavelength until the wavelength that you want to measure at is reached. And let's go ahead and try taking a measurement at 420 nanometers. Next thing you need to do is, using the 0 control, turn the 0 control until you get 0.0 showing up on the display. Next thing you should do is now open up the sample compartment and put the blank solution in. You should always wipe off the bottom of your cuvettes before you insert them in the machine to make sure that nothing interferes with the reading. Also notice that there's a little line shown in the front of the cuvette. Line that up with the dash on the front of the sample compartment, and then insert it all the way inside, and then close the sample compartment. This time you're going to use the absorbance transmittance control and turn it appropriately one way or the other until you get 100 on the dial. Once you've set the machine at 100%, then you can go ahead and take your cuvette out and then put your sample in. Again, making sure that you line up the mark on the cuvette with the mark on the sample compartment. Here you can see that the transmittance value is 93.0%. You can also take an absorbance reading by simply pushing the mode button to go down to where it says absorbance. So when the absorbance LED is lit, you can see that at the same wavelength, the absorbance is 0.032. You want to ignore that. The machine has to be set up specifically in order to use that option, and this one is not. So do not write this concentration down, and you need to know the correct factor in order to set the concentration. So ignore those. Just use the transmittance and absorbance on the machine. When you remove your sample, the machine should return back to 0 transmittance. You can go ahead and continue to put new samples into the sample compartment and continue to take readings at the same wavelength that you just set the machine up for. So if you have 10 test tubes, you can now put all 10 of them in one at a time and note the readings. But once you decide that you want to record a wavelength at a different wavelength, let's say we want to switch from 420 to 480 nanometers, now we have to go through the entire calibration method one more time. So then we'll have to begin by first changing the wavelength to the desired 480. We'll have to zero the machine using the 0 control knob on the left. Then we'll have to put the blank cuvette back in. And then we'll have to use the knob on the right, the absorbance transmittance control, in order to set the machine back at 100% transmittance. And then after that's complete, then you can go ahead and put your sample in to read the absorbance or transmittance at the new wavelength.
Alright. So yan guys, yung medyo luma, no? Old model ng spectrophotometer. Now, in this next slide, we have here a video clip naman of the more modern version ng spectrophotometer, which I think lahat tayo familiar, or almost lahat tayo familiar kasi nakagamit na tayo guys ito before. So let's watch this.
Are you looking for a spectrophotometer that's built to last even in the toughest laboratory environment? Discover the thermoscientific Genesis 30 spectrophotometer. the only unit that delivers the quality and accuracy of a top-of-the-line instrument at an entry-level price. The Genesis 30 features sturdy, lab-tough construction that stands up to the demands of a real working lab. Plus, it's designed for the way technicians actually work, with an oversized sample compartment that makes access easy and cleanup effortless. Use the Genesis 30 with cuvettes or test tubes. Our optional test tube holder includes a depth gauge for easy and accurate fluid measuring, and can handle test tubes up to 150 millimeters with an available tall test tube cover to ensure testing accuracy. Our heavy-duty rubberized keyboard delivers at-a-glance simplicity, and our high-resolution screen is bright, crisp, and easy to read. The built-in Smart Start feature gives you instant access to your favorite methods. 6-point quant sampling means improved data accuracy. For labs that need to scan, Genesis 30 delivers fast, accurate data for peaks up to 3A. Plus, Genesis 30 makes it easy to report your data. Save a data file to a USB memory stick or print it on the optional Snap-on printer. Don't settle for less. Choose the spectrophotometer that delivers more, the Genesis 30.
Okay. So guys, nakita nyo, no, compact yung design. And of course, yun nga, it will really suit your needs kung marami kang i-analyze sa lab. Okay, so you have seen the comparison between the old and the latest model of, or more modern version, guys, ng spectrophotometer. Now we move on to the next part, spectroscopy based on absorption. So when a molecule absorbs electromagnetic radiation, the number of photons that passes through the sample decreases. We call this the attenuation. The measurement of this decrease in photons is called the absorbance, a useful analytical signal. Okay, so yung more common na term kasi sa atin, guys, for sure, ay absorbance. Okay, of course, yung light, guys, that magpapass through dun sa sample, which will reach the detector, will be decreased or lower na yung amount nun because some of the radiation was already absorbed by the sample. Now, we have here symbols that we use in absorption. Okay, so ano-ano yung mga terms na to? We have P0, the symbol for which ang ibig sabihin ay incident radiant power. Ito, guys, ang initial amount of light. Then we have P as the transmitted radiant power. A is the absorbance, T, of course, transmittance, path length, ito yung kaninang value na binigay natin, which is 1 cm, yung common path length ng mga cells. Pwede rin, guys, ang 2 cm up to 10 cm. Depende, guys, dun sa sample cell. Absorptivity is A. And another term na related sa absorptivity is molar absorptivity. Symbol na, guys, ay epsilon. So the first column, ito yung more familiar terms for us. On the other hand, guys, ito namang second column, just in case you come across a very old book or a very old reference, maybe you will see this. Ito yung mga mas lumang terms, guys, na ginagamit in absorption. Okay? So, guys, ito na ngayon yung mathematical part ng absorption, which is about Beer's law. Ito, guys, ang history niyan. Okay? Bouguer in 1729 and Lambert in 1760 noted that the transmittance of light decreases exponentially with an increase in the sample's thickness. Then, in 1852, Beer noted that the transmittance of light decreases exponentially as the concentration of the absorbing species increases. These two relationships, when combined, makes up Beer's law. That's why, guys, in other references, it's sometimes called Beer-Lambert's law or Beer-Bougier's law. Okay, so eto, guys, ang ito ang incident light, P0. So as you can see, siya yung mas malaking amount, diba? And then some of the radiation will be absorbed by the sample. So eto, guys, yung sinasabi kanina na yung photons passing through the sample will be decreased. We call this attenuation. So P is our transmitted light. If we get the ratio of these two variables, we get P, which is transmittance. Ang common, guys, na value ng T ay in terms of percentage. If you will read books, laging percent T yung ginagamit nila. So it's just T times 100. And then, of course, guys, huwag niyong kalilimutan ang A, absorbance. Absorbance is equal to the negative log of transmittance, which is the more common unit for expressing the attenuation of radiation kasi linear, guys, ang relationship ng absorbance with that of the analyte's concentration. So A is negative log of T. So inverse, guys, ang relationship nitong dalawang to. Okay? And according, guys, to Bouguer and Lambert, so P is equal to P naught raised to negative ABC, wherein A, as we have seen earlier, absorptivity, B is path length, C is the concentration of the analyte. So, big A, absorbance, is equal to A, B, C. Alright? So, guys, very simple lang itong approach, itong mathematical approach towards Beer's law. Okay? Then later, we will discuss naman yung mga limitations. May limitations din kasi, guys, ang Beer's law. Even though very good na yung relationship established, no, we're in linear ang concentration ng analyte sa absorbance. Meaning ba, ma'am, kung meron tayong mga solutions ng standards na nakaprepare, tapos may sample tayo, we can readily know kung how much yung amount ng sample, analyte sa sample exactly. Because we can make use of the equation of the line kung saan linear, guys, ang relationship ng concentration with that of the absorbance. Ito na nga, yung limitations to Beer's law. Even though we have established their linear relationship, still, guys, meron pa rin mga drawbacks sa Beer's law which you can avoid. You can avoid the following limitations, okay? So, light should be monochromatic. So, ibig sabihin ba, ma'am, may effect yung stray light? Exactly. So, actually, guys, magkakaroon ng discrepancy sa magiging experimental absorbance ninyo kung may presence ng stray light. Okay? Light that reaches the detector should be transmitted light only. Yan nga. And then there should only be one absorbing species. And take note, kung lagpas, guys, sa 1 ang absorbance na makukuha ninyo for your sample, you have to dilute that. Absorbance of 1, meaning, ibig sabihin, guys, na kapag more than 1 na yung absorbance ng sample ninyo, sobrang taas ng concentration. And there is a possibility na hindi na applicable yung linear equation kasi nasa more than beyond ka na nung kung saan ideal lang yung relationship. Okay? So, you must perform dilution if in case sobrang concentrated, guys, ng sample na sinasubject nyo to your spectro analysis. Okay? So, this works, Beer's law works only, guys, with the ideal conditions kung saan kailangan linear. So, para pala magamit natin yung linearity relationship nila, we should follow certain guidelines exactly. And one of this is to always check the dilution of your sample. Okay? Guys, solve natin itong problem na to. So, we can check kung alam natin yung uses ng mga equations kanina. A sample has a percent transmittance of 50%. O, diba sabi ko sa inyo, T is always expressed as percent. Okay, so ibig sabihin yan, ma'am, 0.5 yung transmittance sa problem exactly. Calculate, guys, natin ang absorbance. So A is equal to the negative log of 0.5. So the absorbance is 0.301. Very easy. Okay, so again, guys, ang relationship ng absorbance with transmittance, negative log of T. Okay, always remember this. Next problem. A 5 times 10 to the negative 4 molar solution of analyte is placed in a sample cell that has a path length of 1 centimeter. At a wavelength of 490 centimeters, the absorbance is 0.338. What is the molar absorptivity of the analyte at this wavelength? If you remember, guys, A, absorptivity, epsilon, yung molar absorptivity. So we have the following values. A, absorbance 0.338, path length 1 centimeter, concentration 5 times 10 to the negative 4 molar. So directly substitute those values. Of course, we have to isolate epsilon at one side of our equation. And guys, direct substitution nyo na. Okay? So you can either pause this video or just continue to know the answer. Epsilon, or the molar absorptivity, is 676 inverse centimeter inverse molar. By the way, guys, ang absorptivity ay property ng analyte. So if you want to check your analytes property, pwede nyo i-check guys ito sa literature. So may mga provided naman guys na values for absorptivity or molar absorptivities ng mga compounds. Alright? So guys, so we are now at our next subtopic, UV-vis. Diba? Common yung term na yun, UV-vis, UV, ultraviolet and visible spectroscopy. So you have this in your manual, the 4 instruments that we will discuss under UV-vis. Number 1, the filter photometer. 2, we have the single beam spectrophotometer. O ma'am, bakit mahaba na yung term? Bakit spectrophotometer na? I'll explain later. And 3, we have the double beam spectrophotometer and the diode array spectrometer. So guys, one by one, ano ba ang pwedeng ma-measure? Okay, ano ba pwedeng ma-provide sa atin using the following instruments? The filter photometer, guys, as you can see the first picture here, it is the simplest instrument for UV-vis absorption. It uses an optical filter to isolate a band of radiation. Ito yung filter na diniscuss natin at the start of this video. So medyo earlier version to guys ng instrument. It has a single optical path between the source and the detector. So ito rin ay maituturing natin na single beam instrument. It is inexpensive, rugged, easy to maintain, and portable. Ayan. Next is our single beam spectrophotometer, the instrument you have seen in the video a while ago. So ma'am, bakit siya single beam? Kasi guys, isa lang yung path, single lang yung path ng light from the source to the sample to the detector. Kaya siya single beam. Mitch, bakit naman tinawag siyang spectrophotometer? If the instrument uses a monochromator as its wavelength selector, guys, yung spectrometer na term, ginagawa nating spectrophotometer. Okay? So, ayan guys, ang single beam spectrophotometer. Now, you will understand, kaya pala double beam, dalawa yung ma-split into 2 yung path ng light exactly. So a scanning monochromator allows for automated recording of spectra. So this is one advantage, guys, kapag may scanning monochromator ang instrument or equipment ninyo. And then, eto na nga yung double beam. Double beam instruments are more versatile than single beam, being useful for both quantitative and qualitative analysis, but are more expensive and not portable. As you can see guys, sa maliit na picture dito, mas malaki ng kaunti yung version guys ng double beam. So in this diagram you will see guys, so we have here our monochromator, kitang-kita guys yung diffraction grating, and then we have optics, okay, for the light to be divided into 2 para siya ma-split. So one will pass through the sample, one will pass through the blank. So ma'am, automatic yung comparison? Yes. Okay, so optics, the optics here will allow you to measure simultaneously. Alright, so para guys mas maunawaan natin, I have a video clip for the double beam spectrophotometer. Let's watch this.
Hello viewers, welcome to yet another video on analytical instrumentation. In this video, we are going to discuss about the double beam spectrophotometer. As we can see in the diagram, this instrument is called the double beam spectrophotometer because it uses 2 beams of light simultaneously. The components are a light source, optical components like mirrors or collimating mirrors, gratings, selector mirrors, multiple sample holders, and a detector. The light source is a halogen tungsten lamp operating in the visible region of EMR and a deuterium lamp which produces UV radiations. The intensity of these black body sources can be controlled by varying the voltage applied to them. The next components are optical elements which are responsible for collimating light radiations and focusing them on diffraction gratings. The diffraction grating separates the wavelength using the Bragg's law. For more information on diffraction grating, you can check the video whose link is provided in the description. By changing the angle theta of light, one can obtain a particular wavelength lambda if the grating distance d is fixed. One can obtain required wavelength by rotating the grating. The monochromatic light exiting the grating assembly is split into 2 parts using a selector mirror. The light beams travel in 2 directions and pass through the reference cuvette and sample cuvette respectively. The final component is a photocell, or it can also be a PMT. PMT stands for photomultiplier tube. It detects even smallest photoelectrons as it has internal amplification assembly. So, even for weakest light intensities, good amount of measurable photocurrent is generated by the PMT. For more information on photocell and PMT, refer to the video on the same. The link is provided in the description below. Now let's understand the working of a double beam spectrophotometer. The advantage of using a double beam spectrophotometer is that the errors due to intensity variations in source of light are eliminated. The monochromatic light exiting the riveting assembly travels in two different paths. One passes through a reference sample or standard sample, and the other one passes through the analyte under test. Both the solutions absorb part of light falling on them and transmit the remaining light. The transmitted light is picked up by the detector and readings are recorded. Since the reference and sample under test are recorded simultaneously, any fluctuations in the light source are eliminated. The concentration of analyte can be determined from the readings of the intensities. Presently, sophisticated instruments are available which directly give the concentration of analyte. Since measurements are done simultaneously, these instruments operate at high speeds. Some instruments have multiple sample holders so that all the samples are loaded once and the experiment is conducted. The variations in the lamp output are compensated automatically. Spectral scan of an analyte is possible using double beam spectrophotometer. And the changes in detector sensitivity is also compensated. That's it for the current video. Subscribe to the channel to stay tuned for some.
Okay guys, so ayan na ha. So very clear naman dun sa diagram yung pagkakapaliwanag guys ng difference ng double beam with that of a single beam spectrophotometer. So mas expensive syempre guys kasi napansin nyo, mas magiging mabilis yung analysis using a double beam spectrophotometer. The fourth one under UV-Vis instrument guys is the diode array spectrometer. Yung detector guys dito which is called the photodiode array detector, it is situated at the gratings focal plane with each diode recording the radiant power over a narrow range of wavelengths. So ayan, so you can see guys here na multiple yung detector sa diode array spectrometer. So if I were you guys, I will read more about UV-Vis instruments. So when you answer specific questions or problems under spectro, hindi kayo mahihirapan. Okay? Kasi mas malawak pa guys talaga yung chapter ng spectro. Here in this video, I'm just giving you a summary of the important topics. Alright? So now I'll be giving you an example of the spectrum. Okay? What will be the output if you perform an analysis? Now guys, itong pagkuha or pag-obtain ng absorption spectrum, this is the first thing that you should do if you haven't checked yet the lambda max of your analyte. The lambda max is the wavelength, your working wavelength for your entire analysis. So, Mitch, paano po namin kinukuha yung absorption spectrum ng isang sample? So, you search sa literature, saan ba dapat i-dissolve yung sample ninyo, and then of course, use your exact concentration, kung ano yung concentration na gusto nyong gamitin, dapat syempre guys, enough yung amount ng analyte ninyo para very distinct yung makuha natin na lambda max. So I'll be showing you guys an example here. So let's define muna kung ano ang lambda max. This is a characteristic of each compound and provides information on the electronic structure of the analyte. So if you want to check kung established na yung compound guys or analyte na nasa study ninyo, i-check nyo muna sa literature, sa mga references, sa mga journal articles kung ano ang lambda max niya at for specific conditions. So you can check kung magmamatch ba doon sa ma-obtain nyo experimentally. Measurements are made using the lambda max in order to obtain the highest sensitivity and to minimize deviations from Beer's law. So guys, ito yung isa sa mga absorption spectrum ko na na-obtain ko during my MS thesis. The compound I'm after, or the compound study ko is called gamma oryzanol, at ang kanyang lambda max obviously is found at 320 nanometers. So for the entire analysis, 320 nanometers guys yung ginamit ko na wavelength. Kasi dito pinaka-sensitive itong compound. As you can see, ayan yung peak ng kanyang absorption spectrum. So very distinct yung peak niya, 320 nanometers. And then, kapag meron na kayong sure guys na value for the lambda max, you can now prepare your standard solutions, to be specific, your external standards. So this is a series of solutions that you will prepare for you to graphically or mathematically determine your analyzed concentration in a particular sample. So guys, ito ang tinatawag na standardization or calibration curve. We have absorbance versus concentration. So guys, yung concentration, of course, ipe-prepare nyo rin accurately yan So you must have at least 5 standards with specific concentrations. Yung sa akin guys, in terms of ppm or milligram per liter. And of course, nakaset na yung instrument at 320 nanometers. So ito na ngayon yung gagamitin ko na standard curve or calibration curve para maka-determine or maka-analyze ng concentration ng sample. Kasi meron na akong standard or calibration curve. Mamuna po yung nakasulat. Ito guys, yung equation of the line. I hope you remember y is equal to mx plus b, wherein m is the slope and b is the y-intercept. So you can easily get this guys through Excel. So if you will input your values sa Excel, x and y, and then you can also get the linearity or the correlation coefficient. So guys, di ba nga, ang goal natin is to take advantage of Beer's law, where in linear ang relationship, there are certain areas kung saan linear relationship ng absorbance with concentration. So we would like the coefficient to be very, very near to 1, just like this one. Okay? Kasi yan yung magagamit natin guys na curve para makapag-determine ng sample ng concentration ng analyte sa sample. Okay? So ayan. Of course, mag-solve tayo ng problem, di ba? Para ma-test natin guys kung naunawaan nyo ba yung sinasabi ko kanina na calibration curve. So, of course, ito guys ay galing sa book ni Harvey. Ayan, napansin nyo blue colored yung solutions because these are yung samples dito, yung external standard na dito ay copper. So as you can see guys, nakamatch yung bawat flask sa certain portions sa curve, sa calibration curve. So, ito guys, define ulit natin although na-mention ka na kanina, external standards are solutions containing known amounts of analyte prepared separately from samples. And then the curve that you are constructing will plot the instrument response, or in this case, absorbance, yung response ng instrument versus known analyte concentrations. Okay? So guys, mag-solve tayo ng sample problem. And this problem, ang analyte ay iron. The determination of iron in an industrial waste stream is carried out by the orthophenanthroline method. Using the data in the table below, determine the amount of iron in terms of milligram iron per liter in the waste stream. So here guys, we have X. Ito ang ating x-axis, no? Ito ang known concentrations ng iron in ppm. And then of course, the absorbance. Guys, take note that when you plot, guys, kapag nag-plot na kayo ng mga external standards ninyo, no, do not include the sample. Baka isama niyo yung sample. So again, guys, so you plot this sa calcu ninyo. I will demonstrate later. So this will be in your x-axis. Ito naman, guys, ay sa y-axis. Now, you might wonder, or baka nakalimutan nyo na guys, although dapat maalala nyo kung paano mag-plot sa calculator, we will be using the stat mode of your calculator guys para malaman natin yung value, okay, yung value ng concentration na meron dun sa sample. So guys, get your calculators. So the model I have here is 570 ES plus Casio. So guys, let's now enter this value. So ang kukunin ko guys, ang una ko nang ginawa guys ay press setup and then I will press 3 stat. So ang stat guys dito sa calculator ko ay 3 So 3 stat. So press natin ng 3 and then meron tayong mga pagpipilian na naman. So ilang variable meron to? 2. So after pressing 3 stat, ito naman guys yung ipipress ninyo 2 kasi this is for the for 2 variables. Okay? So now let's press 2 and we see now guys the stat editor, X and Y. So enter lang natin guys lahat ng values. So we have 0 ppm, that's the first standard. Then we have 1 ppm, 2 ppm, enter equal guys lang ha, kada enter ng value. And then 3 ppm equal sign 4 ppm. Okay, and then up lang guys para ma-enter nyo naman yung Y values. So at 0 ppm, 0 absorbance, equal sign 0.183 for 1 ppm, 0.364 for 2 ppm, 0.546 for 3 ppm, and 0.727 for 4 ppm. So make sure to enter the values properly. Baka guys mamali kayo ng pindot, so the entire equation will be wrong as well. So press AC lang guys, and then press Shift Stat. Nasa key 1 guys yung stat ha, so pa-press nyo yun. And you will see here, 1 type, 2 data, 3 sum, 4 var, 5 reg, 6 min max. We will press 5. So guys, dito ko sinusulat ha, yung mga ipapress nyo in order. So 5 reg kasi regression guys yung gagawin natin. So let's press 5. And we will now see the following. 1, okay, 1 here is A. It corresponds to the y-intercept of the equation. And then 2b guys, ang b sa calc ay slope. 3r, r is the linearity or correlation coefficient. 4 guys ang x hat, and then 5 naman ang y hat. So one way to check kung na-plot nyo ba properly yan is to look for the linearity coefficient. So press 3 equal sign yun. Puro 0.9999. O, diba? Ibig sabihin guys, linear yung equation. So you have did the right thing. Press AC. Press Shift Stat ulit guys. Reg ulit. And then now, makikita nyo ulit yung kanina, no, yung 1 to 5. Ma'am, pwede bang kuhanin din yung slope tsaka y-intercept? Sure, guys. So, ito ang slope. So, ang slope ay 0.1817. Tapos, yung y-intercept naman, guys, teka. So, para lang i-check kung tama yung mga na-plot nyo, no, y-intercept is 6 times 10 to the negative 4. So, ma'am, may paraan din po ba para madaling makuha yung x value at absorbance of 0.269? Madali lang, guys. Kailangan yung kuhanin yung y hat. So you will press 0.269, the absorbance of the sample, unknown yung concentration niya, and then you will choose this symbol, x hat. Okay? So yan guys yung isang shortcut sa calculator para hindi nyo na kuhanin pa yung linear equation and then substitute pa yung values. May mas madaling paraan. Press nyo lang guys ang 0.269. So, and then Shift Stat. Okay? Tapos, reg, and then press nyo guys ang x hat. Yun yung value ng x, given natin yung y na 0.269, and then equal sign, you will get this. The value is 1.477. O, diba? So, ma'am, ibig sabihin po ba niyan? 1.48 milligram per liter ang value ng milligram per liter ang value ng iron in the sample? Yes. So this is an easy way using just your calculator, guys, to get the amount or the concentration of analyte in the sample. So what we did is to plot the values in our calculator using linear regression to find x. Now guys, sa book, erase ko na to ha. Now guys, sa book, you will see nakapag-plot, may graph talaga. So you can actually also perform graphical analysis. So here is our x and y axis. And nabanggit ko na kanina yung slope at saka y-intercept. So you have this equation of the line. Di ba guys, 0.269 yung 0.269 yung absorbance ng sample. So, of course, dahil mag-graphical analysis nga tayo, dito banda kunwari yung 0.269, rough estimate lang guys. And you will see na, yes, tugma nga, siya nga ay around, gitna siya guys, no? It should be at the middle of 1 and 2 ppm. So indeed, the answer is 1.48 ppm. So this is the equation of the line, okay, na nasa form ng y is equal to mx plus b. Okay, so if you think easier yung ginawa natin kanina dun sa previous slide we're in, we just use our calculator, then you can also follow that. Okay, ito naman, may graphical analysis tayo, so we can check really kung doon ba magpo-fall yung concentration ng analyte sa sample. Okay, so I hope guys you now understood kung paano ina-apply paano nagagamit ang Beer's law and getting the concentration of the analyte in a sample. Okay? So guys, we're done with the first 4 subtopics. Yung 4 na subtopic, tapos na natin. We are now at the 5th one, which is atomic spectroscopy. Okay? Overview lang guys ha. Rather, history lang muna. Saan ba nanggaling itong origin ng atomic spectra? Kirchhoff and Bunsen. Yes, ito guys, exactly yung names nila. So if you're familiar with Kirchhoff's law and Bunsen-Burner, ito ang name nila. It was first used, okay, the atomic absorption guys, so atomic emission, they first used this to identify atoms and flames and hot gases. And now guys, sa makabagong panahon ngayon, more than 90 elements were identified using AAS. Ay, teka. Naka-ano pa pala, sorry. Naka-pen pa pala to guys, tong ano natin. Okay. So, ayan guys. Yung picture ni Kirchhoff tsaka ni Bunsen. Ayan. And the spectroscope that they, ito yung similar sa spectroscope na ginamit guys ni Kirchhoff at saka ni Bunsen. So, here guys is the block diagram. Ito guys ang block diagram ng AAS instrument. So, similar parts. Yun nga lang guys, meron tayo dito part kung saan may flame. So you will know later para saan yung part na yan. But if you look at it, kasi ito din guys yung exact parts kanina in our general na spectrometer, diba? So we have our source here. To be exact, for AAS, we use hollow cathode lamp. Then we have flame. That's just one way to atomize the sample. So as you can see guys sa picture na to, you merong sample dito sa portion sa baba because you will be aspirating the sample towards the flame, and then you have the monochromator, the detector, and again the readout. So guys, para magkaroon tayo ng idea how to use an AAS instrument, let's watch this video.
Hello, so now we're going to cover how to use an atomic absorption spectrometer. So it's a pretty hefty instrument. There's a lot of components behind it, which you won't have to worry about. Your TA will have everything set up for you. So in this section here is your hollow cathode lamp, which provides your wavelength. You can also make sure the wavelength will be set here, but your TA will do that. Inside here, you have your burner. And this is where your premixer and aspirator, where your sample is going to be sucked up to go into the flame. And in here, in this part of the instrument, you have your monochromator, your detector, and your amplifier, just to give you a signal. So it all pretty much, all those components allow you to give an absorbance reading here. So those are pretty much the main components. There's a lot of knobs and stuff, but again, you don't have to worry about that for sampling. So just to start up the instrument, give me some oxidized air. Just use a regular sparker. And that's what your flame looks like. You get used to the pump in the background. It's quite warm, so you want to keep the door closed once you have it ignited. You already have all your standards prepared. You want to start off with your 0 because you want to zero the machine. So it's really simple. This is just your nozzle. You insert the straw into your sample, and it automatically sucks up your sample, aspirates it into the flame to create atoms. This is how we atomize your sample. And then once your sample is being ingested by the flame, press auto 0 to make sure your background is corrected for. So once that's accomplished, then it's just really a matter of measuring each standard relatively quickly, since your absorbance is an instant reading. So just sticking that in there, and then you'll see an increase in your absorbance. And it's not quick. You find your numbers fluctuating a lot, feel free to, at any time, take your 0, and you can zero the machine at any time, just to make sure your background is relatively the same for all your standard readings. And then you continue with the rest of your standards, and now you have enough data to build a calibration curve and measure your unknown.
Ayan. So guys, nakita natin, no, ang dali lang mag-perform ng analysis. Of course, hindi na pinakita guys yung sample preparation, etc., yung sampling, ganyan. So what we aim here sa video na to is for you to know yung instrument, paano siya gamitin in a very simple manner. So guys, you have seen there yung block diagram, nakita natin siya in a real life, kumbaga real time, hindi mo real time, pero actual yung instrument. O, di ba? Actual yung instrument na nakita natin dun sa video clip. Okay? So, before tayo mag-move on dun sa part na specific for AAS, yung atomizer, let's first discuss yung first part niya. So, again, guys, the first part of our spectroscopic instrument, of course, is the source of radiation. Here, in AAS, we use the hollow cathode lamp. So this consists of a tungsten anode and the cylindrical cathode sealed in a glass tube filled with neon or argon at a pressure of 1 to 5 torr. The cathode is constructed of the metal whose spectrum is desired or serves to support a layer of that metal. Cathodes of some consist of a mixture of several metals. Multi-element lamps permit the determination of more than a single element. I remember guys, sa lab namin before, hindi pinapahawakan sa amin yung lamp. Okay, kasi nga, yung itong hollow cathode lamp, it's quite expensive. And of course, let's take note guys na ito ay specific for elements, for certain elements. Okay? So, kaya ngayon, pwede na ang multi-element determination. Okay, next part. The next part is, ito naman guys, ay isa pang, ito next part. Ito ay next type of lamp. So this lamp is called electrodeless. Okay, electrodeless discharge lamp or EDL. Yan guys, yung kanina HCl, hollow cathode lamp. Ito naman guys ay EDL, electrodeless discharge lamps. They are useful sources of atomic line spectra and provide radiant intensities usually 1 to 2 orders of magnitude greater than hollow cathode lamps. An EDL is constructed from a sealed quartz tube containing a few torr of an inert gas, such as argon, and a small quantity of the metal whose spectrum is of interest. Okay? Ayan guys, ang EDL. Now, ito yung unique part sa AAS, atomization. The first step in spectroscopic procedures is atomization. So you have seen a while ago sa video clip, so may flame, diba? So that is where atomization will occur. This is a process in which a sample is converted into gas phase atoms or elementary ions. It is the most critical step and the one that limits the precision of atomic spectroscopic methods. So guys, in your manual, you have there various atomization methods used in specific types of spectroscopic technique, ganyan. So familiar tayo sa AAS, AES. So guys, familiarize yourselves with this kasi baka mamaya sa board exam hindi tayo sure kung anong itatanong sa inyo, 'di ba, about AAS. So pinaka-common guys dito, of course, flame. So flame can be used for absorption, emission, fluorescence. And ayan ang AAS, AES, at saka AFS. So other atomization methods are ICP, inductively coupled plasma, electrothermal, DC plasma, electric arc, and electric spark. Okay? And we have two types. In general, we have continuous atomizers versus discrete atomizers. As you will see guys, ang plasma at saka flame ay example ng continuous atomizer. On the other hand, discrete example ng electrothermal, individual samples are injected by a syringe or autosampler. So kung napansin nyo kanina, di ba, may tube na maliit doon na mag-aspirate ng sample continuously. Hanggat may nilalagay kang sample doon, continuously lang guys ang aspiration ng sample. So indeed, continuous atomizer ang flame. So guys, to give you an overview, what happens during atomization? Ito, nebulization, dissolvation, volatilization, dissociation, ionization. So medyo mahaba guys ang proseso, but our goal is to produce atoms or ions. In a flame atomizer, a solution of the sample is nebulized by a flow of gaseous oxidant mixed with the gaseous fuel and carried into a flame where atomization occurs. All right? And then, eto guys, so this is, again, flame atomizer pa rin to, no? So ito guys, so kamukha ito yung burner kanina doon sa video. Ang tawag guys sa burner na to ay laminar flow burner. It produces a relatively quiet flame and a long path length for maximizing absorption. These properties tend to enhance sensitivity and reproducibility in AAS. So ayan ha. So ayan guys ang tinatawag na flame atomizer. Also written here, most reproducible of all liquid sample introduction methods. Okay? So lahat ng mga methods siya guys ang most reproducible. And then, an alternative guys, ito ang example ng discrete atomizer, di ba? Electrothermal atomizer. So you see here sa picture, cross-section view, atomization occurs in a cylindrical graphite tube that is open at both ends and that has a central hole for introduction of sample. Mas familiar ako kanina doon guys sa laminar flow burner kasi ganun yung example, ganun yung burner doon sa AAS instrument sa lab namin before. And then, ayan guys, I'll no longer read ha. In fact, I have provided a PDF file of some of the slides here, especially here guys sa AAS part. So you already have this in your online accounts. All right? And then guys, of course, the third component of AAS instruments is the spectrophotometer. It could be a single beam or a double beam. So we already explained a while ago ang difference ng single sa double beam spectrophotometer. Okay? And ayan, double beam. So you might want to read this guys sa books for you to understand more yung components na AAS na instrument. So, anong difference ma'am ng AAS sa AES? O, napansin niyo itong video na to, itong animation na to, guys. Nakikita niyo ba? O, diba? So, AAS, may hollow cathode lamp. Napansin niyo, natanggal siya. You can deactivate, actually, the lamp for AAS to be converted to AES. An atomic emission spectrometer is similar in design sa instrumentation, guys, ng AAS. In fact, it is easy to adapt most flame atomic absorption spectrometers for atomic emission by just turning off the hollow cathode lamp and monitoring the difference between the emission intensity when aspirating the sample and that of the blank. So kanina guys sa video, ang tawag sa blank ay zero kasi it is used to zero your the absorbance before ka mag-analyze ng mga samples mo. Diba? So yan guys, ang AAS and AES. So for you to know more about instrumentation ng AES, meron tayong example guys dito. Let's watch this.
What's the job of an ICP OES analyzer? To see what things are made of. To do so, fundamentally, the analyzer turns liquid into light and light into answers. To find out exactly what chemical elements are in a liquid sample, the analyzer runs it through an extremely hot plasma. As the heat excites the atoms and ions of the sample elements, they emit light. The analyzer's optical system captures that light and separates it into spectral lines. The intensity of that light is usually related to the concentration of a given element in the sample. So, this is key. By precisely measuring that light intensity, you can determine which elements are present in the sample and in what proportions. Now, let's take a cutting-edge ICP OES analyzer, such as SpectroArcos. Step by step, here's how it works. The liquid sample is drawn into the peristaltic pump. In the nebulizer, it's converted into a fine aerosol spray. In the spray chamber, larger droplets drain away, but finer droplets are directed into the hot plasma. In the plasma, the sample aerosol vaporizes, and its atoms and ions are excited, so that their characteristic wavelengths are emitted. The light is transferred into the high-resolution, no-purge sealed optical system, which separates the light into the specific wavelengths for the elements to be measured. As these wavelengths strike the detector array, light intensities for each different wavelength are quantified, and sophisticated software converts them into concentration units. So the sample secrets which elements it contains in exactly what amounts are revealed. The process is complex, but the results are precise. And those ultra-reliable results make a next-generation ICP OES analyzer, like Spectral Arcos, a truly fundamental tool for busy labs like yours.
Okay. Nakita nyo na guys how the appearance of an EES equipment looks like. At of course, yung working principle niya. Now guys, here are some properties, desirable properties of an emission spectrometer. So we have here high resolution, rapid signal acquisition and recovery, low stray light, wide dynamic range, accurate and precise wavelength identification and selection, etc. Okay, so guys, galing lang sa book to. Ito yung mga hinahanap mo dapat in an AES spectrometer. Okay? So again guys related pa rin to sa topic natin kasi spectroscopic methods naman in general yung topic natin. Now, since ito na yung last natin, last topic natin guys here in Spectro, before moving on to the special topics, alam niyo ba na ang AES is very, very useful if you're going to perform multi-elemental analysis. So you can see guys, the diagram from Harvey, no? Ang daming mata. Ibig sabihin yan, maraming detectors can be used simultaneously. AES is ideally suited for a multi-elemental analysis because all analytes in a sample are excited simultaneously. If the instrument includes a scanning monochromator, it can be programmed to move rapidly to an analyte's desired wavelength, pause to record its emission intensity, and then move to the next analyte's wavelength. Diba? So kaya kanina sabi doon sa video, kung busy yung lab, very perfect daw ang paggamit ng AES for elemental analysis. So atomic emission spectrometers can contain as many as 48 to 60 detectors. Alright, so yan guys, ang last topic natin for this video. This crash course, guys, actually is composed of 2 videos, no? The first one, ito nga, hanggang atomic absorption / emission, and then yung next one naman, guys, are the special topics still under spectroscopic methods. Okay, so as our final problem or final na gagawin guys sa video na to, sa crash course video na to, first part pa lang to guys ng spectro kindly copy this and then fill in the blanks. Alright, para guys, in case na meron kayong ma-meet na acronyms about spectro, alam nyo agad ang ibig sabihin. Meron na akong 3 answer dito AAS, AES, and AFS. We have also seen them a while ago sa table na meron sa manual natin. Alright? So guys, kindly do this as part of your homework, reading assignment, ganyan, para maging complete yung alam ninyo guys about spectroscopic methods. Okay? In the next part of this crash course video, guys, we will discuss specific methods like mass spec. So, 3 yon, mass spec, IR, and NMR. Okay, so ganun pa rin watch the video, read books, and then of course, kailangan nyo ma-practice yung test-taking skills ninyo. Of course, you have to answer the practice tests after watching and after reading yung mga references natin. Alright?